Mario! In this video, the sixth in my cul-de-sac series, we're going to be looking at horizontal alignment. So this here is a roading plan. I've done a little bit of work on the roading plan. I've put it into a template and I've started to detail some of the information we know. So starting at the cul-de-sac intersection here, we know that we've got a 15-metre radius circle here with a 3.45 road width from the centre line. So that tells us that we've got an 18.45 in here to the centre of the circle here and to here, given that the road intersects at a 90-degree angle. So just a little bit of information in there to record this key point here, which is essentially the tangent point at the start of the straight for the curve and channel. So then that brings us along to the curve here. We know this is a 70-metre curve. We know that the tangent points are at right angles to the straight, and so there straight away we can see that if that's 90 at 90, that'll be 180. And similarly, this one here is 66 at 91, 56, 01, 20, and the radius of the circle, so they are both 70 metres long. Now, AutoCAD with the dimensioning tool tells us that that's 23 degrees, 58 minutes, 40. But it pays to check these critical elements as we go along, and the way that I've done that is I've just created a layer called the calculations layer, which I've just put in here for the purposes of just demonstrating the calculations. And I've got a bit of a calculation up here where you can see that, I'll just zoom in a bit better there, where I've put in the 180 degrees, the 156, 01, 20, and subtracted them to get 23, 58, 40. Which agrees, exactly with what we've drawn in AutoCAD itself. Now, that angle there, obviously, if we divide that by 2 on the basis of symmetry, is going to give us these angles here, which gives us a nice little right angle triangle. So in the right angle triangle, if we divide that angle by 2, we get 11, 59, 20. And if we take the tangent of that to work out this, what we call the tangent in here, to work that out, tan 11 degrees 59, 20 times 70, remember this will be 70, gives us a 14.865. And that's our tangent distance in here. We can also work out the length of the arc, but let's just go down into here, into properties, and we'll just do a quick check, and there we are, where we have it, 14.865. So that's checking out pretty good. And then we've got our arc length, which we can also calculate here, 23, 58, 40 divided by 360. That gives us the fraction of the circle that the arc is, and then we multiply that by the circumference of the circle, 2 times pi times r, gives us 29.294, so that should be our arc length. And then we can obviously go down here and check it out, and yes, we've selected more than one thing, so I'll just put that onto the one hit selection, and 29.294 it should be, which is all very good. So now what that enables us to do, of course, is we can calculate some critical changes at this point in time now, and I have done some of this previously, so I'll just turn on, I've got a chainage layer here that I've turned on. I've got a few of the marks, extra marks in there, and I've also put some various marks. No, I don't want to do that just yet. So that gives us the chainage marks, which I've got them all in there ready in their approximate places. We're going to try and work out a chainage every 20 metres. But for the purposes of this calculation here, what I want to show you is that if we go from here through to here, which is a total distance of 70, which is what the brackets indicate, and if we subtract from that 14.865, obviously the distance from there to there, that gives us our chainage, 55.135. Note that chainage always goes along the centre line of the road. So where there's an arc, it goes along the arc. Where it's a straight, it goes along the straight. We always look at the road from increasing chainage. So obviously this is 0, it's increasing this way. If we stand at this point and look up the chainage, this will be the left-hand side and this will be the right-hand side of the road. So that gives us a chainage at this point here called a tangent point, and that is 55.135. Now we've got our arc length, 29.294, which we can add to 55.135, and that will give us a distance of a chainage of 84.429 at this tangent point here. So then it remains just to add on this length from here through to here, okay, and that is obviously the 84,802 minus 14.865, and we calculate that out. I haven't got that exactly to hand at this point, and we add that on to the 84.429, which gives us 154.366 as the chainage distance at the end of the right-of-way there. So that's that chainage point there at the centre of the right-of-way. So there are our chainage points. Now it remains that we want to put a chainage every 20 metres, and so what we can do for that is there's a little feature here that thing can do. So what I'm first of all going to do is I will just make a copy of this little arc here. This is necessary to do. So I'm just so I don't lose it. So I'm just going to select it, CP for copy. I'm just going to select it there and finish my selection. Select the base point there, and then I'm just going to copy it back to there, and then what I'm going to do is I'm going to put it into the my calculation layer, which is here, and I'll probably colour it magenta so that we can see it there as part of the calculation layer. So there we go, we've got it all in there as part of the calculation layer there. Okay. So that's all good. So now I'll also put another couple of lines in here, polylines in here. I'm going to put one from here, like so, through to there, and that's again as magenta. And then I'm also going to put another one in from repeat line from here through to here. Okay, now what that enables me to do is to do a polyline edit, PE for polyline edit, and I'm going to do multiple polylines, and I'm going to select that line there, the arc that I put in there, and the line that I put in there. And they're all the ones, so I'm going to select those, and I'm going to convert those to polylines. Yes, I want to. And I'm going to join them all up, and yes, and they should have all joined together now into one, hopefully one contiguous polyline. And no, it hasn't. Oh, that's no good. Okay, so it's probably because I had my selection tool turned off. So I'm going to just try that again. PE, select that there, I need to go for M for multiple. I'm going to select that. Select that. And select that. Enter. And yes. And then we want to join them. And I should join. And now we have a contiguous polyline there, as you can see. And if we look at the length of the polyline, 154.367, 154.366. So we're 1 millimetre out, which you could expect from rounding errors and things like that. So 154.367, that's all of our chainage there on a single polyline. Now what I'm going to do is I want to put in marks every 20 metres, and so what we're going to do there is we just go up into the home tab, into the drawer, and there's a divide there, but there's a measure here. So select that one there, and I select my polyline, and then I put in, the length is 20, so it's going to put in a point every 20 metres. And then if I turn on my DDP type, okay, and put into this sort of thing here, okay, what you'll see now is we've got a point at every 20 metres, and I've labelled these up previously, 60, 80 and 100, and there's 120. Wasn't planning on 120, and there's one there at very close to 140. I'm just going to use 139.564, and then there's our 54 one there at the end. Now what I then have done is I've actually copied the little peg symbol or wipeout symbol, and in fact what I have done is I've made it into a block. I made it into a block called peg, and then I've been able to copy that into where each one where I want it. So at this point here, what I'm going to do is I'm going to turn off my calculations layer. Just turn that off. So that should get rid of that. I'll turn on my chainage marks. So I put marks. I put my little symbol there. As I said, I actually converted it into a block, and and I'll turn off the DDP type. I'll just go back to having nothing there. Okay, and now you can see that we've got our chainage. I have labelled them previously, so I've labelled all the chainage points in through there like so, and right through, and I've done those in red so they just stand out a bit. So we've got all the chainages, and I've also gone through and named all of the critical points here, and these ones are going to create a table on the plan with the coordinates of all of these points, which should be sufficient for any competent surveyor to be able to set out the details and get things exactly how they're planned. So that's that all done. So I'm going to draw up the table and put that in there. I've also put some details on the curve details. I put a table on that. There's only one curve in here, which is curve 1, and so I've just created a little table and just to record all the details of that as we calculate it. So that's pretty much there. There's a few things to add to the roading plan, so I'm just going to pause for now, and then I'll come back. Okay, I'm back, And I've tidied up the plan, just sorted out a few bits and pieces, and I've added down in here the coordinates of the key points that I've labelled. I'm pretty sure that with this information on the face of the plan, any competent surveyor would be able to have sufficient information there to be able to set out that that design, that roading design, provided of course he had sufficient control had been provided, which I haven't shown control at this point in time. Don't forget the little datum note down here. Coordinate datum is New Zealand Geodetic datum 2000, and it's on the Mount Eden 2000 circuit. So the coordinates are in terms of Mount Eden, the false origin of 800,000, 400,000. Just a few little things that came up in the course of this, and that is that if you create some new layers and things, depending on how you create them. So for instance, if you create a new layer, I'll just get the new layer thing, it creates a new layer in every viewport, unless of course you can use some of the ones that create a new layer viewport frozen in all viewports, which is that one there is a good one to use, because it creates a new layer that doesn't appear in previous viewports. So when you're creating new layers, it's always very important just to go back, and you can see, obviously you can see here that this here is showing through this coordinates layer that I've put the table in, is showing up there. So you really need to turn it off in this viewport here so that it doesn't show up. But if you use the create new layers at a viewport frozen in all viewports, that'll be fine. So sometimes it's necessary to turn some layers on and off. Sometimes it's necessary to move the marks around a little bit from different layers, especially if you're, say, for instance, if we go back to the roading plan here, in future, I've got all of these marks here, the little wipeouts that I've used, and I've must be a model layer, put those into little block reference actually called PEG. I've created a block, but they're all in chainage marks, but so when I will have to change some of those to another layer at a later time if I just want to show the chainage marks on the centre of the road and not these peripheral ones here. But I'll do that as I go along, just having them in different layers. So that's pretty much the roading plan done as such. I will be, as part of the next step in the process, recording this information that we've shown here. I will be recording it on an Excel spreadsheet. Remember that with roading, everything relates to the centre line. So at this stage here, we have sorted out the horizontal alignment based on the centre line, and now we will be moving through to the vertical alignment, which will also be related to the centre line, but may create some other key points that, some other key points that will also may require coordinates, but they should be okay. Possibly we may be able to include additional chainages. You can come back and do that at a later point. So cheers, and we'll see you on the next time.